Now broadcast is online. Hi everyone, I am Hakan Özler, team player of Docker Izmir. Today webinar is about Docker Swarm mode. If currently you use Docker, Docker Swarm or have an idea to use this is the webinar for you. So we are honored today to have Ajeet Raina, Docker captain. Hi Ajeet.
Hi.
How are you?
I'm doing good.
Thank you for joining Docker Izmir and thank you for
Yeah.
accepting us. Uh, if you want, you may want a little bit of background give for yourself, Docker captain. So when you are okay, we can start session.
Yeah, sure. So hello everyone. Thanks for joining the session. My name is Ajeet, and I'm currently in Bangalore, in India, and I am a part of a Docker Captains program in the last 2 years. It's more than I think 1.5 years actually. So we are actually. I'm currently working in Dell, and it has been like last 6 years I have been in Dell. Before that, I was in VMware. And basically this is how on the screen you can see that first half of my career has been in CGI and VMware, whereas second half of my career has been in system integration. So so currently I'm working as a project lead engineer in Dell EMC, and I am more into a kind of a operations team rather than being a core developer. So Docker is something which I started exploring around 3 years back, when Docker was just like, I believe it's 1.6 version, or the release version was there, and at that point, right, there has been a Docker was quite new, so I started exploring it and then leveraging it in day-to-day activities in my office. So Collabinix.com is my personal blog where I usually write the new features which Docker releases, and has been like last I was in DockerCon in the distributed Docker distributed system which happened in Germany. I was part of that, and so I have been visiting places and doing meetups, doing the webinars. That's pretty much.
Thank you, Ajit. Just a reminder, this is just a 1 hour webinar. You can ask your questions to Docker Captain Ajit on Twitter with the Docker Izmir hashtag. So I will check regularly that page. So we can
Okay.
start if you want, if you're okay.
Yeah, sure.
Good luck.
Thank you. So in today's session, I'm going to talk about Docker Swarm mode. Docker Swarm is a native clustering tool which is offered by Docker, and it was announced last year in the DockerCon, and since then there has been a lot of features. So in this webinar, what I'm not going to deep dive into Docker Swarm mode, but give you a kind of a glimpse of what features has been there in last 1 year, and then so the whole agenda will look like this, where I am going to introduce a Docker Swarm and talk about Docker Swarm mode features. Probably the features might include like service discovery and then a load balancing, which I'm going to showcase. And this time I have collected a lot of examples so that anyone who is new to the Docker Swarm mode can get a kind of an idea what the Swarm mode does. Then I'm going to talk about Docker's stack deploy. So if you have an application, any kind of web application, front end, back end, if you want to deploy it across the Swarm cluster, how you are going to do with Docker's stack deploy. Then I will touch upon what are the new features in the latest release, like which is 1707, and I am going to touch upon those features itself, which is very latest. And at the end, I bring you for the first time how to run a hybrid swarm mode cluster on Play with Docker. So this is this is for the first time actually, how the hybrid swarm cluster works. So let us get started. So let us start with a little background. I will start with a little background where, say you started using containers in your infrastructure and you are building a kind of a Docker host. Take it as you start your application in a single Docker host application where you have a number of containers running it on it. And then because of the application, since if you are hosting a kind of a web application, you get more hit, and you need to now scale out your application across a number of nodes. And then you start adding number of host machines. And at this point of time, you might have seen that there has been there are a lot of different aspects to be taken care of. The first thing is, when you have application running across the swarm mode cluster, HA is the first primary aspect. Why? Because at any time your one host goes down, and if the request is coming to the particular, or the request is reaching it to the particular node, if that node is down, how the request is going to serve, how it is going, the node is going to serve the request. Then the other factor is how these applications are going to talk to each other. This is where the service discovery comes into the picture. And when you talk about a large number of nodes hosting a number of services, we call it as an application or a task or the containers, how you are going to schedule it. And if your application needs a frequent rolling updates, how you are going to achieve that. So these are few of the features you want to take care of when you host an application across a number of cluster nodes. And yes, the security is one point where you always, so that any third-party tool or the third-party, third person wants to access your cluster, how secure your cluster is. So taking all this consideration, here is where the Docker Swarm mode comes into the picture. And Docker Swarm is an orchestration tool. It is a native clustering tool which is offered by the Docker. So let us try to understand how the Swarm is different from Swarm mode. So if you say, when you hear about Swarm, it basically indicates a classical Swarm, which was before 1.12 release. Swarm mode was first of all introduced under the Docker's 1.12 release going forward. So currently, if you are installing Docker, by default, the Swarm mode gets enabled. By default, the Swarm is already present there. So what it means is, the Swarm mode is already embedded into your engine. You just have to initialize it with a Docker Swarm in it. Docker Swarm is based on a technical foundation, which is in the form of the repository, which is called as a Swarm kit. So Swarm kit is where all the development activities happen. And once it gets matured, then it comes that the feature is basically integrated into the Swarm mode. Swarm mode consists of one or more nodes, which can be anything, can be a physical or the virtual nodes, which you might be running on, say, a Raspberry Pi or in a cloud, on a bare metal in your laptop. And what it does, it basically enables you to deploy the application across the multiple Docker hosts. And it uses a kind of very intelligent overlay network for the service discovery, and has a built-in load balancer for scaling your services. So when you scale your services, inbuilt load balancer is going to help you out. If you remember, if you have used the Docker Swarm before 1.12 release, you basically depend on the third-party tool like Console for doing a kind of a service discovery. But now with the Docker 1.12 release, you can basically, you have all those features integrated into the Docker engine. And with Docker 1.12, you have a couple of new APIs which has been introduced, just like new Docker APIs, new Swarm CLI, and Node. And with this comes a kind of a CLI tools where you can go ahead and manage your cluster. If you look at the swarm mode under 1706, this is the latest stable release which we have, and there are bunch of orchestration components which has been introduced. Just like service discovery is the one, you have a secrets management, scheduling and placements, distributed store, load balancing, topology aware scheduling, service logs, health aware orchestration, service rollbacks, and the recent one which has been introduced is a Mac VLAN support. So now you can make your container act as a VM. So all those boxes which has been labeled green in color are the ones which are very recently added features in the Docker Swarm mode. I am going to touch upon most of them, but I can't go in one hour time. I can't go around each and every one and explain it. So, but I will explain it. Explain few of the features, important features, which will be essential for both the beginners and advanced level users. So let's get started with this. So before we deep dive into any of the features, let's see how to create a swarm topology. So this will be kind of a recap. Why? Because I have couple of blogs which I have written how to set up the swarm. So you can visit collabnix.com and where you will find a lot of steps there how to build it up. So let's do a kind of a small recap here. Just wait for more minutes. So I'm directly accessing my slides over the slide share which I have done. So I can go ahead and do it directly open it here. So okay, let me see if it comes back. No. Okay. So we'll start with building a swarm topology, and how you build it in the manual way is like you take up the first node, which is your manager node, and you try to say Docker swarm init, and you pass either the advertise address or the listen address. So advertise address is like if you want to listen the swarm on a particular port, you use the advertise address, whereas in the listen address is you want to listen that particular swarm mode on all the interfaces. So this is a way how you do it, and you go ahead and add a node on it. So you say Docker swarm join and with the token ID and the manager node, and this is how the nodes gets added. In the same way, if you want to add more number of nodes, what you do is basically run the same commands on all the nodes. And on the manager node, you can go ahead and run the command docker node ls, and you will see that all the nodes gets displayed. So your swarm is ready. Now, if you look at the few of the features where you want a scripted method rather than going ahead and doing it manually, today you can use Docker machine to basically set up your swarm mode cluster. So this is a snippet of a script which will help you to set up a 2-node swarm mode cluster. If you talk about setting up the swarm mode on cloud, so from Docker, we have an offering called as Docker for AWS, Docker for Azure, and Docker for GCP for each individual cloud platform. Docker for AWS uses an AWS cloud formation. So if you have ever used it, you are a AWS user. So all you have to do is basically go to log into the AWS and open up the cloud formation, and then there you can specify how many manager nodes and how many worker nodes you need, and that will be pushed to the AWS as an instance. So you will have a Docker Swarm mode cluster setup. The same thing happens on the Azure, where it uses a service principal concept and brings up your Swarm. On GCP, we do it with a deployment manager or the CLI. There are two APIs, so CLIs. You can use both to set it up. Now, the interesting thing, which in the last release, we have an interesting topic which is called as an how you set up a hybrid cluster setup, which means that if you have a Windows and Linux machine in an environment, you can today it is possible to set up a Docker Swarm. You can visit the link which I have pasted in the top bottom of this on the bottom of the slide in a collapnix.com, where I have where I have blogged about how to set it up. So at the end of the slides, I am going to showcase how to set up a hybrid cluster. So let's talk about the service discovery, because that is the core functionality where how the Docker Swarm handles the services. So Docker Swarm is built on a service concept. Whenever you type any Docker CLI or a Docker or you have an application which is talking to the Swarm API. So what it means is, when you run a service command, Docker service create, it basically creates a kind of a spec file for the service, which could be the image name, number of replicas which you want to push it to the Swarm cluster, number of replicas of the services, how many copies of the services, replica copies of the services you need on the Swarm mode cluster. And in the spec, you mentioned about the networks which you have, overlay network which you create, then expose post, yeah, all the environmental variables and the placements where you want to place it. So you can define this spec in terms of a Docker Compose file or within a CLI, and that parts get pushed to the Docker Swarm mode cluster. And through the Docker spec, you create a services. So service is a definition of task which has to be executed on the worker nodes. So if you would have run Docker run command, what it does, it basically sets up or creates a container, runs a container on a single host. But when you say Docker service create, basically what you are trying to do is you are creating containers or a service across the cluster. So it is a kind of an evolution of Docker run command. And what it does, it manages a replicated set of containers. So you have so there are two types of services. One is replicated and one is global services. In replicated services, you basically create a copies of a particular service, and that runs a container. Whereas in a global, you ensure that all the nodes, each and every nodes has at least one copy of that particular service. Let me deep dive into how the service discovery works. So service discovery works. It starts with basically it is based on the overlay network. So first you create an overlay network, then you create a service and attach that service to the overlay network, and then you assign a the Swarm assigns a virtual IP server to that particular service, and DNS entry is taken care. Virtual IP address is a private non-routable IP, and it uses an IPVS load balancing. I think the networking team has really did a great job in integrating this feature, because of which now you can ping one service from another sitting on a different nodes. And there is all where the DNS alias mapping and all upon the service names occurs. And through the gossip protocol, which is the protocol which the workers uses to talk to each other, these containers share their DNS mapping. And this is a point where any container on the network can access the service via its service name. So let us look at our first Swarm service, which we are going to create. So I have a 4 node cluster, out of which we have a 3 worker nodes and 1 manager node. So you say Docker network create overlay my network. So it will sorry, this is wrong. So the network should be the collabnet. So it will create a kind of a collabnet network. So usually, by default, when you create a network, you create a network as a user. So it is basically a user-defined network, and with the user-defined network, you have two more networks, which is ingress network and the Docker gateway bridge network. Ingress network is an important network, which is basically an overlay network, which exposes the ports. And what it does, it basically follows a node port model where each service has the same port on every node in the cluster. So whenever you bring out any service, creating the user ingress network, it basically opens up a port on all the machine. And that is the reason, if you have heard about the routing mesh technology, which is a cool technology, this uses an ingress. So I have one slide which talks about the routing mesh, and this works on port 4789. The other network is a default gateway network, which helps you to connect to the outside world, and it uses a network port 7946 for the network discovery. So let's start with creating a new overlay network. So say Docker network create driver as an overlay and the collab net. So this creates basically an overlay network. And now it's time to create a service. So I am going to create a WordPress application, and WordPress DB is a backend. So you say Docker service create. I need a replica 1. So I need a 1 copy of this particular service under the network collabnet, and I have a few environmental variables which I have specified. And this uses an MySQL database. So as seen in the diagram, the green arrow sign basically indicates the network, the collabnet network, and on top of that you have a WordPress database, database application which is running. And as I said, like each service gets a VIP address, right? So here 10.0.2 is basically a virtual IP server which gets assigned. And now we create a front end, which is WordPress app, and that has to be exposed to port 80. So as seen in the diagram, you will see that on the top layer, you have a WordPress app containers, which gets up, and it has a VIP address of 10.0.4. You can inspect the services by filtering and inspection. And this is a command to do it, where you can, it will show you what is the command, the underlying network it is on, or the VIP address. On the right hand side, you can see that the virtual IPs can be displayed through this service inspection command. And if you try to reach out from one of the container different VIP address to on the WordPress app to the WordPress DB, you should be able to reach out to each other. You should be able to do NS lookup and ping. So what does it mean is, if you have two services, front end and back end, sitting on a particular network, you should be able to ping each other. And this is how the service discovery is enabled. This is an important slide which talks about if you have how you basically isolate one service from another. So if I see at this point of time, I have a second service which is hosted on collabnet 1 overlay network. So any container which is sitting on collabnet should not be able to reach out to the other overlay network unless and until you specify through the CLI. So if I want a service application stack 1 to talk to the application stack 2 sitting on a different overlay network, I can make them talk to each other by passing a kind of a parameter while I create a service. But by default, when you create a new overlay network, and if you have a container sitting on that, it should not be able to reach out to the first one. So this is where the concept of the whole networking stack comes into the picture. So let's talk about the load balancing. And I won't be spending a lot of time because I have 3 to 4 slides which I'm going to talk, because it is a kind of, it needs I think 2 to 3 hours to talk about the load balancing itself. So load balancing is a concept which is inbuilt in a Docker Swarm mode, and all it does, it whenever the request come to your server, how this request is going to be load balanced across the cluster of nodes. So it basically distributes the request among the healthy nodes. And one of the most important feature which the Docker Swarm mode introduces is everything is decentralized, and that makes a kind of, and that removes a single point of failure actually. So load balancing in terms of Swarm mode is decentralized, heavily available, and the load balancing instance is plumbed into every container instance. If you see in the diagram here, you both in a Docker Swarm manager and the worker nodes, you see the load balancing feature is being displayed. So it is basically provided by the embedded DNS, and it can be used to discover both the services and tasks. And since this is a web-based services, it uses the IPVS, which is a layer 4, and then it uses a kernel module called IPVS for the load balancing. If you want to see in detail, this is how the load balancing work. So whenever any client access uh, the server or the web application through port 80, so it gets plumbed into a sandbox which is running on a particular host. I have taken a 2 example where I have one host with 10.128.0.4 and 10.128.0.3, and whenever any request comes, since they are in the cluster, so the request goes to the service sandbox. These packets enter into the Mangle table, where the pre-routing firewall mark of 257 happens, and this is all the intelligence which goes on is inside the sandbox. And then IPVS ADM is the utility which uses the firewall mark to round robin across the multiple nodes. And this is how it basically the load balances. And the source netting comes into the picture under the NAT table to ensure that the packet has to come back to the ingress network so that it has to return into the original format. So if you want to see a snippet of this, so you can find out a sandbox ID through Docker inspect for a particular service name, and you will see that it has a sandbox ID and sandbox key. And this is rightly located under the var run docker net ns. And this is the place where the network namespace comes into the picture, which is managed by the overlay network. And if you really want to look into the sandbox and or inspect the sandbox, you can run iptables -t mangle table with NVL option, and you will see that the chain rerouting policy has already been there, where it sets the marks of 257, and then this gets basically rerouted to the port 80. And you can use the ncenter tool also to see basically the Docker output in the post routing, where how it basically takes the packets and then reroute back to the original state. So I think you should visit one of the Madhu Venugopalan video, where he has touched upon internally upon the Docker networking, because this is something which is like, if you are really interested, there are a couple of videos on the YouTube which you can go through it. When we talk about the load balancing, we can't miss out this interesting features which the Swarm mode introduces, is the routing mesh technology, which is often confused with the load balancing. Routing mesh is one technology which helps you to globally publish the ports. Say, under one scenario, if you have, say in the picture as shown, you have a manager and you have a worker nodes, and at any one point of time, the user is trying to access worker 3, which doesn't have any container, still the user will get the response. And this is all the magic which happens through IPVS, the load balancer which works, and the networking sandbox which is there. So, and this all magic happens on the ingress networking features. So operator reserves a swarm-wide ingress port of 80, and this port gets open up in all the worker nodes, and every node listens on the port 80. So this is a kind of a container-aware routing mesh which reroutes the traffic from worker 3 internally to the running containers. So internally from worker 3, it reaches out to the nearest host and reaches out to the container. So routing mesh is enabled whenever you go ahead and create an ingress network and publish a port. So hyphen publish 80 port is 80 is the port of the cluster, and the other is basically the port of the host. So another great feature is the desired state reconciliation. So what it says, like at any point of time when you are creating a service, right? And if you have in a service, if you have a kind of a desired state where these particular copies of service has to be running. So what the swarm mode does, it basically looks for it makes the changes and it combines the changes. So one example would be, if you see this example where you create an overlay network and say, I want a service named as my cloud having a 3 replicas. So you have a 3 copies of it. At any point of time, if I scale it to an 8 copies, or if I say scale it to 8 number of copies, so at this point of time, your desired state is not equals to the actual state. And this is where the swarm mode comes into the picture. And what it does, it basically brings out to the desired state. Now you have an 8 copies of this particular service running. Let's talk about the global services. What the global service means is, this is a one type of service where you want to ensure that every node in a cluster has 1 copy of the particular service, and you do it in a in a one-liner command when say docker service create hyphen mode equals to global, and this takes care of your services. So this might be important where say you are running a Prometheus server or a stack, and you want to ensure that your node exporter has to run on each and every node. So you can use this capability, this type of services, to globally run the particular service on all the nodes at least. Availability scheduling. So this is another most important feature which has been introduced in a Docker Swarm mode. So as seen in the example, if you say you have a node 1 and node 2, which you have specified in a cluster. So your node 2 has a service 1 and 2 instances of service 2 which is running, and node 1 has a service 1 and 1 copy of service 1 and service 2. At any point of time, say if you add a 1 more node as shown in this, and you create a particular service, for this service, if you are lucky enough, like all these services get scheduled in a particular node itself. And just imagine that if the node 3 goes down, at this point of time you might lose, or your application, the user might not be able to access your service, right? So high availability scheduling, what it does, it basically balances your complete infrastructure in such a way where it spreads out the container instead of equalizing the number of container. So to ensure that your service is accessible even if one node goes down. The next new feature which has been introduced recently is topology aware scheduling. And this is a very interesting, interesting feature which was showcased in the last DockerCon, which happened in Austin. So now we are talking about the scheduling in terms of the availability zone. So if you are a cloud provider, you might have seen that you might be running few of the services or an application which are very much restrictive or which are running in a one particular availability zone. And there has been instances where your zone goes down, the availability zone goes down. It means your whole application is not accessible, right? So in a Docker Swarm mode, they have introduced a kind of a topology aware scheduling where it says that suppose in one of the availability zone you have a one instance of service which is running and the other instance is running in node 2, and if the whole zone goes down, so you won't be able to access it. So to implement it, so you run a Docker node update label add data center is equal to east node 1. So this is how you basically use this feature where you label the node saying like, okay, you label it in the form of the key value pair. So data center is equal to east is a key value pair. And then you basically tie your service to this particular constraint parameter or placement preference saying like Docker service create replicas 2, name of the particular service under the overlay network called collabnet, and the placement preference is like spread equals to node dot labels dot data center. So when you specify it, it ensure that your service gets one of the copy of that particular service get placed in one of the availability zone, and this is how you basically a kind of and have an high availability feature also. Another great feature is the placement constraints. Say in your Swarm mode cluster, you have both a Linux and Windows machine, and you have a front end working on a Linux machine, whereas the back end running on a Windows machine. So today it is possible. So with the recent 17.06 release, we have this feature where you can go ahead and create a service with the constraint saying node.platform.os is equal to Windows, and this service gets created on a particular platform. So at this in this example, it is shown like you are running a kind of MS SQL Server Windows image on a particular Windows node. So it will rightly go to the particular nodes and gets created. So this brings us to the demo. So since I have a couple of minutes here, so I will go ahead and showcase a demo. So let me, the first demo which I'm going to showcase is a kind of hybrid cluster setup. So if you have ever used Play with Docker is a platform which helps you to test drive a Docker Swarm mode. So with the new Microsoft, with the new Play with Docker, this is still a beta version. And Play with Docker is a platform which has been created by the two of the Docker captains, Jonathan and Marcos, and they have given me the access about the beta. And if you access microsoft.playwithdocker.com, you can go ahead and create a hybrid Swarm cluster. So this is the first instance, which is created basically a Windows, which creates a Windows instance. So you can toggle it around as you see it in the left, on the left side of the screen. So once you toggle it around and create a new instance, you can go ahead and create a Windows instance. So on a Windows, I am going to run a Docker Swarm init advertise address, and you can pass on the particular address here, which listens on the particular port. And this is how you initialize the Swarm mode cluster. So your manager node is ready, running on a particular Microsoft Windows instance. I will go ahead and create a new instance, which will be on the Linux, which will be a Linux instance, say Docker version. So I have a latest community edition running, and I will copy paste this particular token. So as this tool is in beta version, so you can expect a few things like port mapping and they are still not working. So our Docker captains are working on it. So once I attach it, I can see that one of the node is on Linux and the other node is on the Windows. Now I will go ahead and promote the worker nodes to the manager node. Having two manager node is, at least it is not recommended. It is just for the testing purpose, which I have taken an example. So it's better to have more number of worker nodes. So I will be cloning one of my repository where I have a kind of a Docker stack deployment example where I'm going to deploy an application where it pushes few of the containers on the Windows machine and the other on the Linux machine. So under this, I have a file called as a Docker compose. So as shown, I have a Docker compose file created in this way where I have two services, the Redis and the web as a front end. So I put a constraint saying like, okay, this Redis has to run on the Windows, whereas the front end web has to run on the Linux and exposed to the port 80. Before that, to make it a little fancy, I will be creating a kind of a visualizer tool. So within one Docker compose command, I should be able to set up a visualizer. This visualizer tool give you an idea about how to set up a kind of a visualization so that it becomes easy to understand. So I have a visualizer tool running on port 8080. If you click on it, you will see a kind of a fancy window where it shows the two node cluster, where one is Linux and another one is Windows. Let me go back to the Docker compose file and try to build up a Docker stack deploy. So you say Docker stack deploy and provide a Docker compose and say my app, and it should be able to bring up both the nodes, and you will see that the Redis, which is based on the Nano server, gets created under the Windows machine, whereas the other container runs on the Linux machine. So since I am running a two manager nodes, which is not recommended, I might expect few of the issues here. Let me go back and check. Okay, so it's saying like there are too few managers are online, but it should be good. Let me go back and check in this node. Oh, it's working fine. Now it looks good. So this was the complete showcase of how the hybrid cluster works. So you should be able to access. You can go to microsoft.playwithdocker.com, and you can go ahead and basically specify it. I can use Docker service ps command to see what is the status. So I have picked up from this Docker compose from one of the blog posts where it shows it should be able to open up the port 80 and I should be able to access it. So let me show you.
Sorry for interrupting. I have a question. How many master nodes do we need in production for better orchestrate services?
Okay, so it all depends upon your setup in a production. More number of manager node is basically going to weaken your performance. So if you have a more number of manager nodes, there is basically a raft store, which raft communication, raft protocol implementation, which is happening in the manager node. So at minimal, you need a 3 manager nodes for your cluster, up to the 5, but more than 5, that is going to degrade your performance.
Okay. Okay, thank you.
So since we have time, right? 15 minutes. So let me show you. Let me show you the few example with a play with Docker. So if you are new to play with Docker, play with Docker is something which I really love to use. Why? Because it helps you to bring up a kind of a swarm cluster in a seconds actually. So if you open the play with Docker, you will see that there is a setting sign here, or templates. You can go ahead and choose the template. So it gives an option of having a 5 managers and no workers, and 3 managers and 2 workers. I can go ahead and click on this, and this should set up a 5 node cluster for me. So by the time you can click here and say Docker node ls, Docker node ls, and it should basically build up your 5 node cluster. So let me show, since we have time, let me show you a few of the interesting applications which you can demo whenever you are conducting any meetup or having a webinar. So this is going to really help you out. So let me go to my... So say I will pick up a kind of a WordPress application, which is one of my favorite application, and I can show you about. So I have a Docker stack.yml where I have specified the front end and the back end under this. And so this is I have a backend called as a DB service, which runs the MySQL, and I have a front end called as a WordPress, which does all kind of a service discovery here. I have exposed the port 80 and passed a few of the environmental variables, and I have put a constraint of, okay, this particular service has to go to the particular worker node, right? So let me show in terms of the visualizer tool. So I'm bringing up the visualizer tool so that it becomes more easy to understand. It should not take it takes seconds. Okay, so I have a visualizer tool where I have set up a 5 node cluster. So it shows right here. So let me go back and open a WordPress application, and I have this here. So now I'm going to do a Docker stack deploy and provide this Docker stack.yml and say my end. So Docker stack deploy is a way where you schedule containers across the node of cluster, right? So across the cluster node. So by the time, if you see, I should have a kind of a visualizer tool. As we specified, it should go to the one of the worker nodes. So this is how you say. So the green button here shows that the services are up, which I can verify through this command. I can see that both are basically replicated. At any point of time, I can go ahead and say Docker service and pick up a service name and scale it. So let me pick up the WordPress, and I should be scale it to 10. And if I go to the visualizer, I can see the 10 copies. Since I was restricting it to run on the worker nodes, that is the reason you can see that no instances has been running on the manager node. So this is where the placement constraint come into the picture. So, and let us access it and see when it comes up. So if you see this WordPress application is up and running, so you can go ahead and configure your database. I think I'm pretty much done. Let me go back to this. If there is there any further question?
Let me check one more time. Twitter. I think there is no any questions, but I have one. Ajeet, when databases are our case, which strategy do we consider in Docker Swarm? So I have come up with like mounting volume in only master or something like, or which strategy do you prefer or do you advise?
So at this point of time, if you see the placement constraints, right, mostly we use a spread because that helps you to it helps you to basically spread your application. But at this point of time, I would say that is the spread uh, is one which is supported, and database is something like you really need to take care of persistent storage. You need to have a storage orchestration engine in place, and that should work with whatever the implementation you have been doing, either in the cloud or in your laptop or in your machine. So if you are really doing in the production, yes, you need to ensure that there should not be more copies of database instances running, but rather concentrate on having a storage orchestration engine and map to that particular database. So as you know, the database mostly what we do is we put the data outside the container, right, and that has to be mounted to the storage orchestration engine. So that could be one recommendation.
Okay. Thank you. One more time, let me check Twitter. Yeah, there is no. So I think you are done, right?
Yeah. So I have one more last slide. So I will be I will be in the Mobi Summit. I will be attending the DockerCon and the Mobi Summit, and this time I'm speaking with one of the code community manager whose name is Jonas Roseland on the RackSD, Linux Kit, and InfraKit, how they can basically help us to build a secure VM which can be span across the bare metal across the data center. So if anyone of you are visiting it, do attend the session. So there are a lot of cool stuff which we are going to bring in.
I wish I could, but let's see. Thank you so much, Docker Captain Ajeet, for presenting us Docker Swarm features. So we can end up with our webinar now. See you guys.
Thanks a lot. Thanks a lot. Yeah.
You're welcome.
Thanks all for today's session. Yeah.
See you next time. See you next webinar.
Yeah, sure.
Yeah.
Yeah, sure.
Bye.
Yeah. Thank you.